All right, guys. I'll be talking about launching our the final perp decks that we ever need in life. I'm actually just kidding. Um, we have enough of those. So, yeah, my talk is about say it 3 times fast, and then you'll figure it out. Who's got it? Say the bottom side, bottom one. Sovereignty. Okay. So, going to talk a bit about sovereignty, a bit about me before we start. So, throughout the talk, I want you to remember I've been in Cosmos for 6 years. It'll make sense towards the end. Built a bunch of DeFi apps, launched a bunch of stuff. I'm based in Berlin. I'm Croatian. I'm one of the founders of Binary Builders. We're an infra shop, slowly transitioning to an application shop. So we have some mobile apps coming up, and we're also playing around in the Web 2 world. We built a builders program, and we help teams go to market. All right, I need to catch my breath. Okay, so what is sovereignty? Well, we all know the definition of sovereignty. Supreme power of authority, or authority. But in the crypto scene, we've all associated sovereignty with something that has been told to us by the Cosmos ecosystem, and these ecosystems that want you to launch an L1. But if we really dove into sovereignty, we can break it up into 2 different categories. First, we have security, and second, we have execution. And both these categories separated are what make Celestia. So starting off with sovereign security. Sovereign security is having your own validator set. It's by having your own validator set, you need to incentivize your validators. Most of these tokens end up being down only. Very few actually make it. And they have a high operational cost. Now we see in the picture that these networks have a large amount of validators. These are the networks that you can assume have made it. But how many have actually failed because they chose to take sovereignty for granted and take sovereign security and sovereign execution together? What do users actually care about? They care about sovereign execution. Now, what is sovereign execution? What does it give you? It gives you ownership of your application. Now, how many of us have built on an existing global state machine, Solana, Ethereum, and so on? My guess is a large amount of people in this room. We've all run into scaling issues. Most of the talks earlier today, the 3 perp dexes that are launching on Celestia, all moved from an existing ecosystem to their own sovereign execution environment because they wanted to own the stack. They wanted simplicity. Bullet, I think it was Bullet, went with the sovereign SDK because they wanted to control the stack. Of course, they have the SVM, but they wanted to control the stack to be able to do more than what you can do in a virtual machine. They wanted performance. All these virtual machines, they give you performance, some more than others, but nothing can beat the native ecosystem, the native compiling. But what does sovereign execution actually give you? What is it actually the first definition of sovereign execution? It's actually Web 2. When you're building a Web 2 application, you own the stack. You own the whole flow of the application. You own the server. It's simple and it's performant. You don't need to build this whole, oh, I need a validator, I need this, I have all this operational overhead. You spin up a server, Next.js, and it's there. And that's what we're trying to achieve with the rollup ecosystem. Now, taking a step back, let's think about what is Celestia. So Celestia is a data availability layer. Cool. Like, does retail care about that? Not really. It's also consensus. It gives you the fundamental building blocks to allow you to build a sovereign execution environment so you can control the stack. Celestia isn't for the retail user. Celestia is to build applications that actually scale and that you can control the stack with. Finally, it's modular. But there's more. So like I said, the native application ecosystem is what Celestia gives you. As we can see, consensus is the beginning. Data availability is starting to tingle in the brain. Modularity, but the native application is the final step where you really can control what you're building. It gives you the ownership. It gives you performance. It gives you bridging and simplicity. Now there's a bunch of people who have built this, and Nisha also took on this approach. They built an L1, but they're allowing people to build sovereign execution environments to enable more, and they're using Celestia underneath. So now tying it all together, I think, now we've come down to Rollkit. Rollkit is what the talk is named, but Rollkit is a library to build L2s, the native app SDK. So Rollkit before was an, how to describe it? Rollkit was a framework to compose an application, and it was really tied to the Cosmos SDK. And now Binary, we're coming in with the help of the team of the previous Rollkit team, and really coming in and redefining it as a performant library to compose, oh, closer? Okay. To compose a sequencer, to compose your application. Instead of what you had before, instead of having to worry about and be pushed into a direction that you may not want for your application, instead you can compose a based rollup, you can compose a single centralized sequencer. Really, you can compose any sort of rollup you would want. And finally, with the new refactor that we've been working so tirelessly over the past couple months, it's execution agnostic. Previously, the execution environment was tied to the Cosmos SDK. Now, we all know how much we love the Cosmos SDK, right, guys? Well, now, before, if you wanted to use EVM, you had to go to the Cosmos SDK. Now you can just use Reth out of the box. You can use different execution environments, trying to get Diego to put the SVM and move in there too. And so there's really, the execution environment is really free to what you want to do, and you can really use it in any way you want. You don't even have to use an execution environment. With Viet, we were talking about maybe putting Express.js on top of it and just building a REST server that posts to Celestia. Kind of these applications that Rollkit is meant to enable is not only for a blockchain, not only for a rollup, but also taking the existing user base of different libraries and just putting it on Celestia. So this gets us to Rollkit v1. Rollkit v1, if you want to use it, reach out. It's definitely a lot of fun. It's a lot simpler and a lot more performant. It's very exciting. And finally, so Binary was the core maintainer of the Cosmos SDK for 3 to 4 years. Before that, we were working on Tendermint. And through that time, we've learned so much of what is missing when you're building an application. So much of that complexity that teams have run into when they're using the beloved Cosmos SDK has been the pain. And so we took a step back, and from the learnings of our rewrite of the Cosmos SDK and where we wanted to go, we began to write a simple Rust state transition function called evolve. And so evolve is meant to be a simple performant Rust, simple twice, because we're not trying to recreate something super complex. The Cosmos SDK is super complex. All these frameworks out there who are claiming to be performant, who are claiming to be this amazing next generation thing, they're super complex to use. When you start coding on them, you lose sight of what you're actually building, and your product becomes more on the software that you're writing than on the product you're developing for the users. So if you want to use Evolve, it's nearing completion for testnet. We've integrated it with Comet already. We're integrating it with Rollkit, and so you'll be able to really use it and play around with it and really see how writing Rust is, but also actually be able to launch a protocol within a couple weeks instead of a couple months. So finally, if you're coming to Berlin for Berlin Blockchain Week, you can come pet Duke. Duke's the golden retriever. And if you want to use Rollkit v1, integrate it, migrate to it, or work with Evolve, reach out. Definitely happy to help. Questions? It's going to be in the stores. It's going to be in test flight soon, but it's heavily. So everyone here has probably used Tinder at some point in time. So imagine Tinder, but swiping left and swiping right is buying and selling leveraged perps. It's for retail. Trading apps are too complex. Talk to you later.
Can you just go a little bit more into Evolve and like what you see the advantages are and what it's for, what it's built on?
Yeah, so it's really just a simple Rust state transition function. And so we really wanted to hone in on the state transition function more so than everything around it. Everything around it can be, like you can take Reth, the Reth provider, you can take Comet, we're working on integration with Commonware, with Rollkit. All these things are very modular, but the state transition function is where the business logic happens. And so we're trying to make that as simple as possible, but also doing fun stuff to reduce the cycle count because we wanted to make it as ZK-friendly as possible. And so it's really just simple Rust. Like we're not trying to recreate the wheel or create something super complex. And then the performance, it's less so in the state transition function and more so on the database. And so we're working with a couple teams out there, Commonware being one with their NEDB, working with some engineers from the NOMP team, and one engineer from the Kronos team who rewrote some Rust libraries for performance. And so we're really just kind of trying to keep it as simple as possible, not super complex, and really hone in on getting users to production faster without having to worry about all this bloat. And so that bloat is really what we've learned in the Cosmos SDK was to use the Cosmos SDK, there's so much to think about. There's so much overhead. Writing a module is super difficult. And then interacting with it is like this huge thing that you have to worry about. The binaries are massive. Here, we're just trying to keep it simple, keep it dumb, reuse existing stuff that enable people to move faster.
So that code snippet got me excited because it looks vaguely like Substrate. Are you familiar all with?
I've written a lot of Substrate.
Yeah, so I was going to say this sounds like Substrate but easy mode.
It's Substrate is extremely like hard and hacky, and so friends with a lot of the Substrate engineers, and yeah, it's like if you want something simple in Rust, it's like you can write it in the mod or outside, but the mod kind of like keeps it nice and clean.
Gotcha. And so ultimately, is this effectively a single state transition function? You can think of it like in the Substrate parlance, it would be a single palette that is the entire state transition function.
Yeah. So it's like you have the module, so like everything's an account, and so then you like staking is an account, bank is an account, all these things, and then you register those in a state transition function, and then that state transition function kind of handles the routing and everything for you.
Gotcha. And when you say it's ZK friendly, are you thinking about doing cross compilation for like RISC-V and the whole ZKVM ecosystem? Or?
We are exploring it. Like me and the engineer who were writing it, and now we have an engineer who's more ZK oriented coming in and like helping with the optimizations, and so we've already added a couple optimizations that he's recommended to reduce the cycle count. So we will get there, but since it's new to us, then he's the one kind of like doing the designs, then we're doing the implementation.
Gotcha, exciting.
Where does the Cosmos SDK go from here?
I think it should continue on like, honestly, the Cosmos SDK shouldn't change. Like, I think the software is capped in the potential. I think that it in my opinion, like it caught up to where the industry was 6 months ago. And with the software stack, with Comet, we have to also not forget Comet started in 2014. The Cosmos SDK was started in like 2016, 2017. And when at certain times there should have been a rewrite before the ecosystem got large, but the ecosystem got large of users. And now to rewrite it, like we did it, we rewrote it, but it was so breaking for users that they didn't want to accept it, and so the ICL team reverted that, and they're kind of continuing on the current path. But overall, the software feels a bit capped, in my opinion, on like the potential. Like the future, in my opinion, is more ZK oriented, and the Cosmos SDK to get it to a ZK point You have to like delete a bunch of code. You have to rewrite a lot of code. And we got modules compiling to RISC-0 when we were working with RISC-0 on it, but the code didn't even look like the Cosmos SDK anymore. Well, more like an ex-wife. But no, I think it's in good hands. I think like they're taking it in the right direction. They're taking it in a similar direction, just at a different pace than what we were taking it at. And I think they'll do well.